Okay, so what we're going to do is we're going to break down our factoring into the different techniques that we're going to use, and then we'll put them all together in the end to figure out how to apply them to any factoring problem we have. So the first factoring technique that we need is finding a greatest common factor, factoring out what is common as a factor of all of the different terms we're looking at. So in order to do this, we're going to start by looking at the coefficients, and we'll find the largest number that divides into both coefficients. And when you did this in pre-algebra, you made factor trees, and it was all very involved. But hopefully at this point, as I to the next page, you can look at these particular numbers and you can find the largest number that divides into all of them. So if I were going to do that here, I'm just going to write GCF equals. Okay. Something that goes into 42, 63, and 21 is certainly 7. But is there a larger number? Do you notice 42 and 63 are also multiples of 21? So we want to include the largest number that divides into each one of these, right? So same thing if I'm looking at just the numbers. I'll do the variables in a second. The numbers here, 12 and 24, well, 12 goes into 24. So the largest number that divides into all of those, or both of those, would be 12. Now you need to also look at the variables. What part of the variable, how many variables are going to be in your greatest common factor or your GCF? And the rule for that is right here at number 2. For each variable, the GCF will contain the smallest. That's the critical step. The smallest power of that variable that you see in all of the terms you're trying to factor. What's the lowest power of each variable that you have? So in this first example, I have a s cubed, an s squared, and an s cubed. So the smallest power would be s squared. And that would be my GCF of these 3 monomials here. If I'm looking at the second example, I have 2 variables, so I'll take them individually. U to the 4th and u to the 5th. The smallest one there would be u to the 4th. And then I have y squared and y to the 7th. So the smallest one there would be y squared. And that would be my GCF for that second group. So that's finding the GCF. The main thing we're going to do with it is factor it out front. So let me just go back. There's a reason I selected these examples in the beginning, because we're going to relate them to our factoring process. So in this second example here, if we were to find the GCF, which would be negative 3x, and pull it out front, then here would be the remaining factors, the things I have to multiply by that to get the original things I started with. So the reverse of this distributing would be factoring out the GCF. So what we're going to do, sounds like I got an email. What we're going to do is we're going to find the GCF first, and then we're going to put that in front of the parentheses. See this in front of the parentheses. And then what we need to put inside is, what do I have to multiply by that to get the original term that I've had in my polynomial? So let's give it a try. I'm going to make these a little bigger. So you need to start by figuring out what your GCF actually is for the polynomial, just like we did in the last examples. So with the numbers, what's the largest number that divides into 45, 15, and 30? It would be 15. So I'm going to include 15 in my GCF. And then I look at my variables. What's the smallest power of y that you see? It would be y to the first. So there's my GCF. Now I'm going to put that out front. And to figure out what goes here, I need to basically ask myself, what do I have to multiply by 15y to get 45y to the 5th? So do it again, do the numbers first, then the variables. What do I multiply by 15 to get 45? That would be 3. And then what do I multiply by y to get y to the 5th? So if I have 1 here and I need 5 at the end, I need 4. Whoops. I need to be on the pen mode. I need 4 more y's. Okay, so continue along that same pattern. What do I multiply by 15 to get negative 15? Well, that would be -1. You don't have to write the 1. You could instead just write negative. It's up to you. And then what do I multiply by the y to get y squared? I need 1 more y. And last but not least, what do I multiply by 15 to get 30? That would be a positive 2. And what do I multiply by y to get y? I don't need any more y's. There's 1 y here and 1 y there. So I don't include a y in my final term. And now I've factored out my GCF. Okay, so I want you to try the second one. Write down what your GCF is first and then factor it out front. Take a second to pause the video and do that, and then start it up again. All right, let's check and see how it went. I found my GCF to be 4a squared b squared. I pulled it out front, and what was left inside was 4b cubed plus 3ab plus a. I can always check this by distributing this back into here and make sure that my result ends up being what I started with. It's a great way to check. A couple other aspects about GCF, and we are going to need this first one in one of our techniques that's coming up called factoring by grouping. Just like if you had, let's say, a times b plus a times c, and I could factor out that a, the a doesn't have to just be one thing. It could be something that has 2 terms. So for example, in this one here, I have x times y minus 4 minus 3 times y minus 4. So the thing that's common is the y minus 4. I can factor that out front. I need to put parentheses around it because it is more than one term. So I have to group it together as this thing. And what's left? If I take out the y minus 4 from here, I'm left with just x. If I take out the y minus 4 from here, I'm left with minus 3. So it is possible to factor out a common binomial, 2 terms, okay? And it's just the exact same process. And I just want to point out back in our multiplying, remember when I did this one using the double distributive? And so I put the 3x in front of here and the 4 in front of here in this step. Do you see how the 2x plus 7 is a common binomial and we could factor it out? In this case, just write it behind instead of in front. And what I'm left with is 3x minus 4. So that's what factoring out that common binomial is basically doing. It's kind of the reverse of that step of the double distributive. Okay. I think that's the main other GCF. I didn't write one here, but I'm just going to point it out real fast since it's not listed. You can also factor out a negative. And so this will also become useful in a couple of places. So let's say we had negative x squared minus 4x plus 3. And in a future technique we're going to use, we're going to really want to factor when the x squared is a positive. And so the way to deal with that is just pull the negative out. And when you pull the negative out, all that's doing is changing the signs inside, right? Because if you were to distribute a negative back in, it's like a -1, it would change all the signs. So that is a common technique we might use. And another place that we would use it is, let's say we had something like, oops, 2 minus x. If you were to factor out a negative from that, so that would switch the signs on the inside, make the 2 negative and the x positive. Notice that you could rewrite that as x minus 2. So factoring a negative out of a subtraction problem just switches the order of the subtraction, right? And so that is going to be another handy fact we're going to use as we continue to work through our factoring.